Hello everyone, so now we are going to start the STP. STP is a spanning tree protocol. This is a very important protocol because if you remember, whenever we are taking the switch and whenever we are connecting, if you see here, I connected with the one cable and then I will connect with the another cable. And what I can do, I can remove this port because you cannot see this ambert color. So here in the option preference and always show the ports, I will uncheck so you can see here. And if you see here, this they are taking some time. We are going to discuss, like they will go in the listening, learning and forwarding. Later we are going to see that one. Now just we need to observe what they are doing here. When we connect the cable to the switch, if you see, one cable is started working here and here, and this one is working, but here it is not working. Generally for redundancy purpose I can connect more than one cable. Example, if this cable is broken, the other cable will start working. That's why I connected the extra cable. Example, I will take one more cable, I will connect like this. If you see, this cable also going to take some time. After that this port is going to block. In short, what we can say, only one cable is working, remaining cable is not working. It is stop. If you see, I can zoom in here. If you see, only the green one is working, other one is stop. So if you see, here is green, so this cable is working, and here all are green, but here is not green, it is not working. So generally, if all the cables are working same time, if any one computer is sending any packet from here, any frame, it will go like this, and we have other computer where we are sending, it need to reach to this computer, but with the other cable it will come back like this if this cable is working, and again it will go like this, it will again come back. So we will have loop in the network. Let me repeat what I am saying. First of all, we need to know redundancy. First of all, we need to know redundancy. What is redundancy? We should know that one. Redundancy means having more than one. Example, if something go wrong, other thing should work. So for redundancy purpose, we are connecting more than one cable. For redundancy purpose, I am connecting more than one cable. When I connect more than one cable, okay, all cables are good, no issue, but one cable is working at a time. One cable is working at a time, other cable is not working because of STP. STP is a spanning tree protocol. We can say STP is a spanning tree protocol which is going to remove the loop from the layer 2 network. So we will have the loop in the network when we connect more than one cable, and the frame will go like this and it will come back again. So we will have loop. When we have the loop, same packet will be flowing in the network. Same frame will flow again and again. Now we are taking example of only one frame. Imagine here maybe 25 PCs are connected. Here 25 PCs are connected. These 25 PCs are sending some data to this 25 PC, and we don't have STP. All links are working, means nothing is blocked here. So same packet is going and coming back again, going and coming back again. It is creating the loop in the network, and we will have the issue. The CPU and RAM of the switch will go high, and it is creating the broadcast storm. To stop this one, we have the STP. STP, they are going to check and they are going to see where loop is creating. They are going to block that link. There is the algorithm, spanning tree algorithm is there. They are going to use that one. We are going to see theory, all detail. Now just I am giving you overview to understand the concept. What I am saying, whenever we take the cable and connect more than one cable, automatically it is blocked because one path is there. If I remove this cable, example, if you see the above cable, this one, if I remove this above working one, I remove that one. So after that, you have these two cable, it will take some time, then one cable will start working. Okay, STP will check and they will say, okay, now no cable is not there, it is not working, so I need to allow one cable to start working. If you connect more than one, they will say I have more than one, I will block that one. Because why they are blocking? So we should not have the loop in the network. Generally we will have loop in the network. Generally we will have loop in the network if we disable the STP. By default STP is enabled. By default STP enable. If you see now it become green. So now data can go here from this side. There is a time listening, learning, forwarding. We are going to see that later. Now just I want to show you when we have the three cables are connected, only one cable is working, remaining cable as a standby, it is blocked. When I remove one cable, after some time the other cable start working. If you see here and here both are green, data can move from this link, but this data will not go from this link because still this link is blocked. And this will be standby. If anything go wrong with the first this link, then this link will start working. Why we have like this? Because if you send some data, it will go with this link and again it will come back with this link. If this link is working, same data will rotate in the network and you will have the loop in the network. We will say to remove the loop in the layer 2 network, we use the STP. Spanning tree protocol is a protocol which is used to remove the loop from the network. Spanning tree protocol is a protocol which is used to remove the loop from the network. By default it is enabled. If we want to disable, we can disable, but don't disable this in the production environment, you will have the big problem. So now let's see the theory. Just I give the idea. You understand or any confusion here? What I explain? Just we are saying in simple language, we are saying whenever I taken the two switches, I plug the cable. Generally I am using one cable, but now I told okay I will connect the more than one cable. So we will have the redundancy. If anything go wrong with the one cable, data will go with the second cable. But when we connected, we will see one cable only working, other cable is not working because STP is blocking the other cable. And why only this port is blocked, why not this port is blocked, we are going to see after some time. Because STP is going to run the STP algorithm depending upon some criteria, STP is going to block some port. We are going to see that in detail. So when I remove one cable, automatically the other will start and you can see both are green, data will go with that one and this will be still blocked. If I cut this above cable, then after some time this will start working. Who is taking care of this one, starting or blocking the ports? This one, STP is doing that one. STP is a spanning tree protocol which is used to remove the loop from the layer 2 network. Spanning tree protocol is a protocol which is used to remove the loop in the layer 2 network. We can say that one. It is taking some time, they will listen, they will learn, they will forward. We are going to see that states after some time, so that's why they are taking some time. After that it start working. Now if I connect again, they will do some calculation and only one link will work, remaining link will stop. So who is doing this one? STP. By default STP is enabled in the CISCO switch. If we want, we can disable also. How we can check if STP is there or not? I will show you. There is one command we can use. So now if you see, they are taking some time. After that it will start working, only one link, remaining link will be blocked. Example, if I want to check, I can log into this switch and here I can write show spanning tree. For which VLAN we want to check, we can write that VLAN number. I write show spanning tree. If I want to check for particular VLAN, I can write that VLAN number. Example, if I want to check for VLAN 1, I can write show spanning tree VLAN 1. With this command we can check. If you see, when I write here show spanning tree VLAN 1, it is showing only for VLAN 1. Here we can see VLAN 001. And here we are getting some information. No need to worry about this information. This information we are going to discuss after some time. What is this, what is that, all we are going to check. Excuse me. Now you need to remember, whenever we are writing show spanning tree, VLAN, whatever VLAN you want to check, you can write that VLAN number here. If you want to check for all the VLAN, just write show spanning tree and press enter. Whatever VLAN is present in that switch, separate STP is going to work for that VLAN. We are going to get that detail. But currently in this switch we have only one VLAN, that's why we are getting only one VLAN information. If you see spanning tree enable protocol IEEE is showing here, and this is the information we are getting when I write show spanning tree. If I give space and write VLAN 1, we will get for VLAN 1. If I give space and write VLAN 10, we will get for VLAN 10. If you want to check for all VLAN, we will write show space spanning tree and press enter. Whatever VLAN is available for all VLAN, it will show you that one. How we know? We can see this one. If you see VLAN 001, this information from here to here for VLAN 1 STP. If we have VLAN 10, you will get below, but currently we don't have, that is not coming. And if you want to disable, how we can disable? We can go in the global configuration mode. We can write no spanning tree, and for which VLAN we want to disable, we can write. Example, if I want to disable for VLAN 1, I disable that one, no spanning tree VLAN 1. With this command I can disable. And if you write show spanning tree VLAN 1, you can see you will get no spanning tree instant exist, means we disable the spanning tree. So with this command we can disable, but don't do this in the production environment, you will have big problem. Generally we will not disable, but I shown you there is an option. If you want to disable, we can disable. Now I am enabling this one. So when I write spanning tree VLAN 1, it enable. If you check now, it will show you it is enable. Okay, before when I check, it is showing it is not enabled here, but now when we check, it is enabled. That's why you are getting this information.